This is page 9 of transformations. So first thing we're going to do is we're going to graph this function right here, which is the x cubed function lowered vertically by 2, right? So just to make things step by step, I will first draw the x cubed function, which we know is 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. So it looks kind of like this, right? So this is just x cubed. X cubed minus 2 would be a lower version of that by 2 units, right? So instead of being like this blue one here, it would be like this green one, okay? So I just drew x cubed minus 2 right there. And now what we're going to do is we're going to look at reflections, okay? So reflections are not too difficult. It's just something that you need to memorize, just one little detail, which is, do you see how there's two kinds of reflections? One of the reflections has the negative on the outside and one of them has negative on the inside. Well, remember, when you have any kind of adjustment on the inside of the parentheses, it's a horizontal. And then whenever you have some kind of adjustment on the outside, it's a vertical transformation. So when it says negative f of x, negative on the outside, that would mean it flips it vertically. So in that case, all the green points are going to flip vertically over the x-axis, okay? So like, for example, the green point in the middle becomes that point there. The green point on the right side becomes that point. The green point on the left side becomes that point. It would look kind of like this, okay? So that would be negative f of x. And then the other function that we want is f of negative x, so that would be a horizontal flip. And so then we would have everything being flipped over the y-axis. So like this point here would become this point here. This would stay the same. This point here would become this point here. So it would become the yellow function there, okay? So this one I did in yellow, this one I did in red, okay? Basically just need to look at the negative sign. Where is the negative sign? Is it outside or inside? If it's outside, I flip it vertically over the x-axis. If it's in the inside, I flip it horizontally over the y-axis, okay? It also says to find these expressions in simplest form. So let me do that. So for this one here, basically the negative goes on the outside of the f, which would be negative x cubed minus 2, right? If I wanted to find it in simplest form, maybe I would distribute the negative sign. So that would be my simplified expression. And then for the yellow one, that would be, I would insert negative x in for every occurrence of x. So instead of something cubed minus 2, I would put negative x parentheses cubed minus 2, which is equal to negative x cubed minus 2, because the negative to the cubed power would just be negative. Okay, so that would be the yellow function expression. Okay, let's go down a little bit. Now we're going to take a look at the summary here. And this summary basically is just talking about, you know, in the general case, when you have the negative sign on the outside, we reflect it vertically over the x-axis, okay? We reflect it vertically over the x-axis. And then when you have the negative on the inside, we reflect it horizontally over the y-axis, okay? And let's see, now let's go down to 5e. And we're going to do A, C, and E. On the same set of axes, sketch the graphs y equals f of x and y equals negative f of x for the following functions. So first I'm just going to draw the axes, And then I'm going to draw the parent function, or the original function, which is a slope of 3 and a y-intercept of 0. So it would be basically this straight line here. And then I'm going to flip it. I'm going to do a vertical reflection over the x-axis. So basically this point here would become this point here, and this point here would become this point here, and it would just be the opposite slope. Okay, so that was A. Now let's do C. So x squared, that of course is the, oops, I'm sorry, I did it in blue instead of red, but whatever. Okay, I'm going to draw a x squared function, which is a parabola. I'm getting pretty experienced at doing that. And I'm going to draw the reflection over the x-axis. So it's a vertical reflection, and it's over the x-axis. So I'm going to flip it over that line. So basically these 2 points become these 2 points, and the vertex stays in the same place. And then positive 4 becomes negative 4, right? All the y coordinates become negative versions of themselves. Okay, so that is my reflection there. And now let's do E. In E, it's x cubed minus 2. Oh, x cubed minus 2, it's the same one we did above, right? So the one we did above, it's saying do the vertical reflection. And so it would just be the red function above. So this would be the red function above. Okay, so since we already know how to do that one, why don't we do a different one? We could do this one here. We'll do natural log of x. Okay, if you remember, how do you graph natural log of x? The way you graph natural log of x is you do OIB to infinity OI, right? So what is the base in this case? It's E. So let's graph these points. So 0, negative, infinity is down here. I should do it in blue. 1, 0 is here. And E, 1 is 2.7, 1. It's about there. Okay, so that's the natural log function. And now I'm going to do a vertical reflection over the x-axis. So that means that this point stays the same. And instead of E, 1, it becomes E, negative 1. And instead of 0, negative infinity, it's 0, infinity. So it looks kind of like that. Okay? So instead of doing E, we did D here. Okay. Now the next one. So for 2, we're going to do 1 and 2 only. And we're looking to do the horizontal reflections over the y-axis. So for the first one here, we're going to do the original function, which is 2x plus 1. 2x plus 1 is a slope of 2 and a y-intercept of 1, so that would be just like that. Okay, and then we're going to do a horizontal reflection over the y-axis. So that point would become this point, and this point would stay the same, and this point would become this point. So the green line would be the reflection of the original function. Let's do this next one here, x squared plus 2x plus 1. Actually, I'm doing this in the wrong order. I'm graphing them instead of finding the expression, but it's okay. We'll go back and find the expression right after this. So x squared plus 2x plus 1, probably the easiest way to find x squared plus 2x plus 1 is to plug in some numbers here. So for example, I'll just plug in these basic numbers here. If I put negative 2 in there, I'm going to end up with 4 minus 4 plus 1, it would be give me 1. If I put negative 1 in there, it would be 1 minus 2 plus 1, which would be 0. And if I put 0 in there, I would get 1. And if I put 1 in there, I'd get 1 plus 2 plus 1, which would be 4. Okay, so basically it would be negative 2, 1, negative 1, 0, 0, comma 1, and 1, comma 4, which must mean that the other one is here. Okay, so that is my function. And then I'm going to do a horizontal reflection over the y-axis of this. And so that means that this vertex goes over here. This point here becomes this point here. This point stays the same. This point becomes this point. This point becomes this point. So it looks kind of like that. So that would be my horizontal reflection. So this actually is answering part B, which is to graph the two. Now, how do I find the expression, the simplified expression for the horizontal reflection? You can see that all I need to do is convert this into the box form. And then I put in negative x inside the box. So it would be 2 times negative x in parentheses plus 1, which is equal to negative 2x plus 1. Okay? And just going to okay. And then what about this one? So for this one, I'm just going to plug the negative ones into these two boxes, or the negative x's. So it would be positive x squared minus 2x plus 1 would be the simplified expression for the second one. Okay, let's look at number 3. The function f of x equals x cubed minus natural log of x is reflected in the x-axis to g of x. Find g of x. So remember, if we're reflecting in the x-axis, that means that it's a vertical reflection over the x-axis, right? So a vertical reflection is equivalent to negative f of x. So g of x is equal to negative f of x. So let's simplify that. So we're going to put negative, and then we'll just put f of x in parentheses inside. And so if we simplify it, it'll be negative x cubed plus natural log of x. And that's it. That's g of x, okay? They wanted to know the expression for g of x. That's the expression for g of x. Number 4, the function, and then they give us this huge polynomial, is reflected in the y-axis to g of x. If we reflect in the y-axis, that would be a horizontal reflection, which would mean that g of x is equal to a horizontal reflection. So that would be inside the parentheses. I would put f of negative x, right? And so what does that mean? That means I'm going to first write my polynomial as a bunch of boxes instead of x's, so I don't get confused. And then inside the boxes, I put negative x in parentheses in each one. I don't have room to write the parentheses, but you know what I mean. So I'm going to have negative x to the 4th minus 2, negative x cubed minus 3, negative x squared, and then 5 times negative x is negative 5x minus 7. So here's my expression. If I have negative to the 4th, then the negative goes away, so it's just x to the 4th. If I have negative x cubed, then the negative stays, so it would be negative x cubed without parentheses. If I multiply negative times the subtraction here, it would be positive, right? So negative x parentheses cubed becomes negative x cubed without parentheses. The two negatives multiply times together, and then we get plus 2x cubed. Minus x in parentheses squared is the same thing as x squared with no negative sign. And then I multiply it times the subtract 3, and that gives me minus 3 here. Okay, so here's my g of x function simplified. All right, and that's it for this page. Let's move on to the next page, page 10. The function y equals f of x is transformed And we can see here that it is going to be a vertical reflection over the x-axis, right? Because the negative is on the outside. So it says find the points on g of x corresponding to the following points on f of x. Now remember, whenever you do a vertical reflection, basically if you have like two coordinates, then basically what you're going to do is you're going to leave the x coordinate the same because it doesn't move, and then you're going to make the y coordinate the negative of whatever it was. Okay, so 3, 0, how would that change? Oh, we're only going to do 1 and 2, okay? 3, 0, 3 stays the same, and the 0 becomes negative, but negative 0 is just 0, so actually there's no difference, okay? What about number 2? So for number 2, the 2 stays the same because the x stays the same. The y coordinate, negative 1, becomes positive 1, okay? All right, let's do the next one. So now what we're going to do is we're going to take f of x, and it's been transformed to these g of x points. So these are actually g of x points, okay? And so now we're going to go backwards, okay? So instead of, so the x is going to stay the same again, and then basically the y coordinate is going to invert to whatever the other sign was. So 7, negative 1, if that's g, the original f coordinate is going to be 7, positive 1, right? And negative 5, 0 is just going to be negative 5, 0, and nothing changes because the negative of 0 is 0. Okay, so the procedure for A and B is the same, because like whenever you do a vertical reflection, basically what you're doing is you're keeping the x coordinate the same, and the y coordinate you're flipping back and forth between positive and negative. Okay, so number 6, the function y equals f of x is transformed to h of x equals f of negative x. So this would be a horizontal reflection over the y-axis, right? So then it says find the image points on h of x for the following points on f of x. So basically what they want, the image is like the reflection after it already occurs, or the transformed point. So we start out with these points on f, okay, and we want to know what the h function point is. So we just need to do the transformation on it, which is we're going to take the x coordinate and we're going to invert the sign, and the y coordinate is going to stay the same in this case. So the 2 is going to invert, and the negative 1 is going to stay the same. Okay, the 0 is going to invert, so it doesn't really change, and the 3 stays the same. Okay, so that's the procedure that we do for a horizontal reflection, right? And then finally for B, we're going to do 1 and 2 again. We're going to find the F coordinates that correspond to these H coordinates. The process is basically the same. So, you know, it's like if you have a certain point here, and let's say it's F, what would be the G point? The G point would be over here, right? It would be on the opposite side. And then basically all you're doing is you're inverting the X coordinate, right? And what if you start with the G? How do you get the F from that? You invert the X coordinate. So you just like go back and forth the same way. So for B1, it's the same thing. We're just going to invert the X coordinate and we leave the Y coordinate the same. And we invert the X coordinate so the 0 stays the same and then the 3 stays the same. So that's it. All right. All right, let's go down and do number 7. So number 7, here is the reason why we need to do these interpretations without actually doing them algebraically, because sometimes they're going to give you a picture and you still need to be able to figure out the transformation even with just a picture. Okay, so we have this picture here, and then we're going to draw the graph of the vertical reflection of this picture over the x-axis. Okay, so for example, we're going to take this point here, which is 3 units above the x-axis, and then I'm going to draw it down here. This point here, which is 3 units above the x-axis, we're going to draw it down here, because I'm just reflecting them over the x-axis, right? And then I got this point here, and then this point here, it becomes this point here, and this point here becomes this point here. And so basically we end up with this upside down spoon, okay? And so that would be this here. And then for B, which is a horizontal reflection over the y-axis, that would be, I'm going to take this point here, and then I'm going to, it's 3 to the left, so this will be 3 to the right. This point here, it's 1 to the left, so it'll be 1 to the right. This point here would be here. This point here would be here and here. And so it would just reflect the spoon over the y-axis, and it would be kind of a reversed spoon, right? So that would be part B. Finally, number 8, a function f of x is transformed to the function g of x equals negative f of x of negative x. Describe the nature of this transformation. Well, look, not only are you doing a horizontal reflection, you're also doing a vertical reflection. So basically, you just end up with, let's see, I'm going to just draw an example for you, okay? So if I have this original function, and first I do a horizontal reflection. If I do a horizontal reflection, it would be here, right? And then if I then did a vertical reflection of the green one, I would end up with, let's see, this, right? And so if I go back and I say, okay, what I'm going to do now is I'm going to compare the red one with the blue one. So what is the transformation to go from the blue one directly to the red one? I don't know if you can see this, but this is what they call a rotation. So if I rotate the original function around the origin by 180 degrees, I would end up with the red function. Okay, so this would basically be a 180 degree rotation. And I don't even need to say clockwise or counterclockwise, because 180 degree rotation, it doesn't matter if you go clockwise or counterclockwise. You end up in the same place, right? What about B? If 3, negative 7 lies on f of x, find the transform point on y equals g of x. Okay, so in this case, remember, g of x is a 180 degree rotation, or we're basically inverting both the x and the y coordinate. So if we know that it starts out as 3, negative 7, basically we just need to invert both of these coordinates, the sign, and then we would end up with the rotated point. So the 3 would become negative 3, and the negative 7 would become positive 7. Because all we did was we did two reflections. We did an x-axis reflection and a y-axis reflection. So the x-coordinate reflects and the y-coordinate reflects. So that's pretty easy to find that. Part C, find the point on f of x that transforms to the point negative 5, negative 1. Again, same thing. If we just want to go backwards, negative 5 started out as positive 5, negative 1 started out as positive 1. Same procedure, right? Okay, so I think that's it for page 10.